Ever wondered how scientists measure the universe, from the tiniest particles to the vastness of space? Stick around, this video unravels the physical quantities, the very building blocks of science. But first, here's a fun question for you. What do you think is the only base quantity that has a unit named after a scientist? The answer will be revealed along the way, so stay tuned. What is a physical quantity? It is anything that can be measured. A physical quantity is expressed by a magnitude, which is the size of a quantity, and a suitable unit, or a standard measure of a quantity. Let's consider some examples of physical quantities and how they are expressed. The length of a football pitch is about 100 meters. Length is the physical quantity, 100 is the magnitude or size of the length, and meters is the unit of length. The other example of a physical quantity is mass. For instance, given a 5 kg metal ball, mass is the physical quantity, 5 is the magnitude of mass, and kg is the unit of mass. This is how all physical quantities are expressed. They should have a magnitude and a unit. A quick challenge right now, take a look around. Can you identify 3 physical quantities around you, maybe the time on your watch, the volume of your water bottle, or even the mass of a book on your desk? Write them in the comments below and share your observations. There are 2 types of physical quantities, base quantities and derived quantities. Base quantities are fundamental physical quantities. These quantities contain only one unit. There are 7 base quantities, which are length, mass, time, temperature, current, amount of substance, and luminous intensity. This table depicts the 7 base quantities with their standard unit and symbol. By the way, the answer to the earlier question is temperature. The Kelvin unit is named after Lord Kelvin, a renowned scientist in thermodynamics. The other type of physical quantities are derived quantities. These are quantities that consist of 2 or more base quantities. They have a combination of units. There are several derived quantities. Some examples of derived quantities include speed, volume, density, force, and pressure. Derived quantities can have 2 or more of the same base quantities, or they can have 2 or more different quantities. For instance, volume and speed. Volume is equal to length times length times length. As noted, it consists of the same base quantity. Speed, on the other hand, is equal to distance over time. As noted, speed consists of different base quantities. Another challenge, imagine you're a scientist measuring the speed of a car. If the car covers 500 meters in 20 seconds, can you calculate the speed? Try it out and drop your answer below. Hint, use speed distance to stand time. To recap, a physical quantity is anything that can be measured. All physical quantities are expressed by a magnitude with a suitable unit. There are 2 types of physical quantities, base quantities and derived quantities. There are 7 base quantities, which are length, mass, time, temperature, current, amount of substance, and luminous intensity. There are several derived quantities such as speed, volume, density, force, and pressure. From the tiniest atom to the vast expanse of the cosmos, physical quantities are what allow us to measure and make sense of the world. Now that you understand the basics, here's a teaser. In our next video, we'll dive into scalar and vector quantities, the forces behind everything from wind direction to acceleration. So, stay curious, and I'll see you there.